I have here a problem from the 2009 AP Calculus BC exam, and this is part A of question 4 from the free responses, and we are given a differential equation dy dx equals 6x squared minus x squared y. And we are also given that there is this particular solution f of x, y equals f of x, solves this differential equation. And the particular solution is that f of negative 1 equals 2. And we'll get to that later in the question, but for now it's asking us simply to start at x equals negative 1 and use two equal steps of Euler's method to approximate f of 0. So we have a difference of 1 here, so those steps are each going to be 1/2 in size, and we're going to use Euler's method to get from x equals negative 1, where f of negative 1 is 2, to approximate f of 0. So let's do that. Let's recall that whenever you apply a step of Euler's method, you have a certain point of your function, and you consult with your differential equation at that point to figure out what is your slope, and you go a certain step, and then you find a new point. So let me do that in a new color. And then from this new point, you get a new slope, and you follow that new slope, some step size, and you go here. So from that point, if this was a general Euler's form, you could continue and do a new point and follow a new slope. But we only need to do this for 2 steps on f. So let's figure this out together. Well, we already know what f of negative 1 is. It is 2. So we know that our first point has x position negative 1 and y position of 2. Therefore, the slope at this first point, dy dx, is given as this function of y and x. Well, we know y and x are negative 1 and 2, so we can just plug them in. 6 times negative 1 squared is 6, minus negative 1 squared is 1 times y is 2. So we get 6 minus 1 times 2, that's 6 minus 2, that is 4. And that tells us that the slope at negative 1, 2, which is our first point, is 4. Well, if we're going to be taking 2 equal steps, as we discussed earlier, this means that each step is going to equal, well, getting from negative 1 to 1 is just negative 1 to 0 is a step size of 1. So that means 2 steps, step size of 1/2. So our next point is going to be at 1/2 plus negative 1, which is negative 1/2, going halfway to 0. So our next point is negative 1/2. And what is the y position? Well, it's 2 where we started, plus 1/2 times the slope, because we're following half of it. So 4 divided by 2. That tells us same thing as negative 1/2 for the x, and then 4 over 2 is 2, and 2 plus 2 is 4. So now we have this first step out of the way. Let's compute the second step. And it is, again, size of 1/2. But now we have a new x-coordinate, so we're going to have a new slope. So let's calculate out what could this new slope be. Well, the dy dx at negative 1/2, 4 is what the slope is going to be. So first we have 6 times x squared, and x is negative 1/2. Negative 1/2 squared is 1/2 squared, which is 1/4. So this is going to be times 1/4. And from that, we subtract negative 1/2 squared again is simply 1/4. And we multiply that by y, which is 4. Now let me scroll down a little bit here to get us some room. All right, so we can evaluate this. This tells us that the slope at this point is 6/4, which is 3/2, minus 1/4 times 4, which is 1. 3/2 minus 1 is 1/2. So if we know that the slope at this negative 1/2, 4 point is 1/2, we can apply our second step of Euler's method, step size 1/2, to find the final point. And let's do this in a new color to make it flashy so we know what we're doing. So we have, again, negative 1/2 plus 1/2 to go forward on the x by 1/2. That puts us at an x position of 0. And of course, it's the y position that is where things are going to get interesting. So we have the 4 from where we were before, plus, and then we have a step size of 1/2 times the slope. Well, the slope in this case is simply 1/2 also. And when we multiply this out, we get 4 plus 1/4, so the x position stays 0. 4 plus 1/4. Well, 4 we can rewrite as 16 fourths plus 1/4, and this makes it quite simple. We realize that at 0, the y position is 17 fourths. Another way to write this is the x position is 0, and the y position is 4.25. So, to answer the original question, if we're going to go up here, f of 0, as we remember, is 17 fourths. So we could write f of 0 equals 17 fourths. And that wraps up part A of this question. I will see you in the next video for part B.